All right, so last class we talked about vertex form of a quadratic, and we learned that the a value gave us a few important pieces of information. If the a value is positive, it means that your graph is concave up. If the a value is negative, it means that your parabola is concave down. We also learned that if we have things like y equals 2x squared and y equals 1/2 x squared, this guy right here is very skinny. And this guy right here is very wide. So the larger that your a value is, the skinnier your graph gets. And the smaller, and when I say smaller, I mean in between 0 and 1, it makes your graph very wide. We learned that the h was our horizontal transformation. So if we had something that was like y equals x plus 3 squared, this gave me a vertex of -3, 0. If we had something like y equals x minus 9 squared, this gave me a vertex of 9, 0 as my vertex. So whatever is inside the parentheses with the x, your vertex will be the opposite of that value. So my h value moves my graph to the right and to the left. We learned that the k value shifts my graph up and down. So if k is positive, it moves it up, and if k is negative, it moves my graph down. So for homework last night, I wanted you to make a rough sketch of these parabolas. So here, based off of this, I know that my vertex will be the opposite of that +3, 3, 5. And because this value out front is just a +1, I know that I can go over to -3 and up 1, 2, 3, 4, and 5. And I know that I can just make a rough sketch here. My domain is all real numbers. My range is y values that are greater than or equal to 5. And my axis of symmetry is x is equal to -3. Here, another rough sketch. My vertex here will be -5, -6. It's the opposite of this value that's in here and the same. So this is the x coordinate. This is the y coordinate. My domain is all real numbers, and my range, it looks like it got cut off in this video. Let's sketch my graph first before we fill in the range. So my vertex is -1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, and 6. Here's my vertex, and because my a value here is -1, this is concave down. Concave down parabola. So my range, it looks like it's y values that are less than or equal to -6. Okay? So moving on, let's start with this one. Let's talk about making accurate graphs here. Okay? So that means I want to plot more than just that one vertex value. So I'll make a table of values, my x and my y. I know that my vertex is -3, 5. We already gave ourselves a rough sketch. Now we're trying to create some accurate graphs here. So in the middle of my x column, I'm going to write -3 and 5. And my x values that are here are going to be some x values that are a little bit smaller than -3. And my x values that go over here will be a little bit larger than -3. So now what I can do is I can take that -5 and I can say y equals -5 plus 3 squared plus 5. So I can say that y equals -5 plus 3 will give me -2 squared plus 5. Y equals -2 times -2 is 4 plus 5. So here, this will give me a value of 9. So let's do another one together. Let's do -4. Y equals -4 plus 3 squared plus 5. Y equals, I'll simplify my parentheses before I simplify my exponents. So this is going to give me -1 squared plus 5. y equals 1 plus 5. So this value here will give me a 6. At my negative 2, I can plug in y equals negative 2 plus 3 squared plus 5. So y equals, this will give me 1 squared plus 5, which will give me 1 plus 5, which will give me 6. And lastly, y equals negative 1 plus 3 squared plus 5. So this will equal negative 1 plus 3 is going to give me 2 squared plus 5, which will give me 4 plus 5. So here I'm at 9. So I'll come over and I'll plot my vertex negative 1, 2, 3, up 1, 2, 3, 4, and 5. And I'll plot negative 1, 2, up 1, 2, 3, 4, 5, 6, this value right here. Negative 1, this is 6, 7, 8, and 9. Negative 5, 1, 2, 3, 4, 5, and I'm up here at 9. Negative 4, and I'm up here at 6. And now I've plotted 5 points of my parabola, and I can sketch in my parabola. My domain is all real numbers. My range is y values that are greater than or equal to 5. My axis of symmetry is x is equal to negative 3. Let's do one more together. This guy was also from your homework. So let's create our table of values. First things first. My domain, or sorry, not my domain, my vertex here, looks like that got cut off. My vertex is 4, 1. So I'll put a 4 and a 1 in the middle of my table. The values up here will be a little bit smaller than 4. The values up here will be a little bit larger than 4. So y equals 2 times 2 minus 4 squared plus 1. Or 2, we'll do the parentheses first. This will give me negative 2 squared plus 1. This will give me negative 2 squared is 4 plus 1. This will give me 8 plus 1. So when I plug in 2, it looks like I get 9. Let's try 3. Y equals 2, 3 minus 4 squared plus 1. This is going to give me 2 times negative 1 squared plus 1. This will give me 2 times 1. Negative 1 times negative 1 is positive 1 plus 1. This will give me 3. So it looks like I'm here at 3. Let's plug in 5. Y equals 2, 5 minus 4 squared plus 1. This will give me 2. 5 minus 4 is 1 squared plus 1. 1 times 1 is 1, and that will give me 2 times 1 plus 1, which will give me 3. Last value before we can plot our points. Y equals 2, 6 minus 4 squared plus 1. 6 minus 4 is 2 squared plus 1. This will give me 2. 2 times 2 is 4. Plus 1. 2 times 4 is 8 plus 1, which gives me a 9 value here. So I'll go ahead and I'll erase these values and I'll plot my points. Let's use a different color this time. How about green? So let's go over to 2 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. Over to 3, let's see, 1, 2, 3 and up 1, 2, 3. Over to 4, 1, 2, 3, 4, and up 1. Over 1, 2, 3, 4, 5, and up 1, 2, 3. Over 6, and up at 9. So here, hopefully yours will look a little bit better than mine.